Hello and welcome to Mclean 360. In this video, I want to solve a problem with you to illustrate balancing of rotating masses. All right, so let's read the problem together and solve it. All right, now a shaft. So a shaft carries 5 masses, A, B, C, D, and E, which revolve at the same radius in planes which are equidistant from one another. The magnitude of the masses in planes A, C, and D are 50, 40, and 80 kilograms respectively. Now the angle between A and C is 90 degrees, and that between C and D is 135. Our task is to determine the magnitude of the masses in planes B and E and their position to put this shaft in complete rotating balance. All right, so that is the problem for us. So how do I go about this problem? The first thing I want to do is to come up with the angular settings. At this point, can you pause the video and come up with the angular settings to show all the angles? All right. Okay, so there we are with the masses. Now, let's say that this angle, let's say that the first is actually the mass A. All right, let's say this is mass A. And then let's say that this is mass C. And we are saying that the angle between A and C is 90. All right. So the idea is that mass A is a reference. In other words, we are referencing mass A at 0 degrees. And we are taking all the angles from mass A. Mass A is actually 50. All right. So mass A is actually 50 kilograms. And then mass C is giving us 40 kilograms. However, all right, and mass D was giving us 80 kilograms. Now we said the question said that these masses revolve at the same radius. So if this is R, this is also going to be R, and this is also going to be R. But then he said that this the angle between C and D is 135. So it means the total angle here is actually 135. Is that right? Between C and D. We don't know about B and E. So for now, let's hold on. But we need another information from the problem to be able to solve this problem. We need another information to solve this problem. And that information will come from the axial distances along the shaft. All right. So can you also pause the video again and look at the axial distances along the shaft? All right. All right. So there we are with the masses. Now this is L. In fact, this is also going to be L. This is also going to be L. The radius of rotation is the same. And then this, this is coming from the fact that if you look at the problem, he said that they revolve at the same radius. And so that is the R in planes which are equidistant from each other. And so if I take the distance between any two planes is the same. All right. Now, this is it. So I have mass A, mass B, mass C, mass D, and mass E. All right. So I want to get a table, and this table will come with every information given in the problem. And then this table will help me to solve all the unknowns. So at this moment, I want you to also pause the video again, and let's see if you can draw the table. All right, very good. Now we have our table ready. And where's our table? Our table is here. All right. Now we want to complete this table. If you are watching this video as a student, I want you to draw this table so that we can copy and complete this table together. So I'm waiting for you. Draw the table and let's learn together. Okay, so I believe you have drawn the table. So let's copy and complete the table. I have it here. So I have plane A, plane B, plane C, plane D, and plane E. And this plane contains masses. And this mass, the first mass was given as 50 kilograms. So this is 50. And then mass B, we don't know. So let me call that MB. Mass C, we know. And what is it? It's actually 40. Is that right? C is 40. And mass D is 80. E, we don't know. Is that right? Now the radius is the same for all of them. So this part is going to be R. All right. At this point, we are going to do multiplication of the mass and the radius. And so it's going to be 50R, MBR, 40R, 80R, MER. All right. Now we want to look at the angles in degrees measured from the first mass. And so if I look at, with respect to mass C, it's going to be 90 degrees. So this is going to be 90 degrees. The idea is that we are saying mass A is actually the reference. Okay, mass A is the reference. We don't know the angle. In fact, we are asked to find that one. We have been asked to find the angle. Now let's look at this. So if I want the angle D mixed with A, I'm going to go all the way from here and then come here, which is going to be 90 plus 135. That is going to be 225. And that is going to be for D. So it's going to be 225. 225. Now I don't know E. All right. So we are going to do this MR, then we multiply by the cosine of the angle which we have here. All right. So what is cosine 0? Cosine 0 is going to be 1. Is that right? Cosine 0 is actually 1. So I don't need to bother about here. It's going to be 50R. All right. Now, after here, I'm going to do MB multiplied by R, and then I'll do cosine theta B because I can't evaluate it. Now, when I get to this point, cos 90 is actually 0. Cos 90 is 0. It means this is going to be 0. And then when I come to this point, I'll do 80 cosine 225. And what is that? Minus 56.569. Or let's take it to 2 decimal places. Minus 56.57. So minus 56.57 multiplied by R. Now this one, I can't do anything about it. So it's going to be ME multiplied by R sine theta E. I'm sorry, cosine theta E. Cosine theta E. So I'm done with this part. Then I will do the same thing for this. This time around, instead of sine, I'm going to do cosine. Sine 0 is 0. It means that this part will be 0. Is that right? And then I'm going to do MB multiplied by R sine theta B. Sine 90 is going to be 1. Sine 90 is 1. And if sine 90 is 1, then it means I'm going to just do 40R. Okay. And then when I get here, I'm going to do the same thing. So 80 sine 225. And what is that? It's going to be the same as the cosine. So it's going to be minus 56.57. So minus 56.57 R. And this one is going to be MER sine theta E. Okay. At this point, we need to eliminate one of them to be able to solve it. Clearly, we have to choose a parameter with more unknowns so that we can eliminate. Now, they all have R within them, so that is not a problem. but I have MB and sine theta B here. So I need to find MB sine theta B. I need to also find ME and then theta E. Now, it is of good choice to some moment about one of these points. And so usually I prefer choosing a point with many unknowns. Now, I can either do it at B or either do it at E, because B and E relatively have many unknowns. So the choice is yours. I prefer taking the moment at point B. So if I decide to take the moment at point B, then point B becomes my reference. And so in that case, I will say that point B is my reference plane. So every distance here is going to be positive and every distance here is going to be negative. Now, if that is the case, then it means that L is 0 for B, and so is every term containing L. Now, if I want A, it's going to be what? Minus L. For C, it's going to be L. And then for D, it's going to be 2L. Finally, for E, it's going to be L plus L plus L. So that is 3L. I'm going to fill the column here by using MR, which I got here, and I'll multiply by the L. So it's going to be minus 50 RL. Now I'm going to also do MR, which I got from here, multiplied by L. Don't forget that this is 0. So it will make this also 0 because MR cos theta is 0. Is that right? Now when I get here, I will actually multiply minus 56.57 by 2. All right. So minus 56.57 multiplied by 2. And whatever I get, I'm going to get, so minus 113.14. 113.14. Then I'll add RL to it. So that is when I multiply this by 2 and then R and L. Finally, for this one, I will have to just write 3RL and then I'll do ME cosine theta E. And then I'll come to this part. You know, sine 0, MR sine theta is what? 0. It means this is going to be 0. Is that right? And then at this point, I will do MR sine theta, which is this, and then L. So I'm going to do 40 R times L. Now, when I get to this part, in fact, it's going to be the same thing. So it's going to be the same thing because MR cos theta and then MR sine theta are the same. 113.14 RL. And then finally, I'm going to do 3RL ME sine theta E. Okay, now let's fill this column, which is MRL column. Now, if I am interested in the first part, then it's going to be MR, which is 50 times this R, and then multiply by this. So I'm going to do minus 50 RL. This one is going to be 40 R plus L. So 40 RL. Then I have 80 R multiplied by 2L. And so 80 multiplied by 2. 160. So I'm going to do 160 RL. All right. And then finally, I'm going to do 3 ME RL. All right. Now, at this point, to be able to solve this problem, there are two approaches. Now, I am teaching you one approach in this video, and that approach is what we call the analytical method. If I want to use the analytical method, what I will do is that I will take here, I will say that summation, so summation of MI cosine theta I multiplied by LI from I equal A to I equal E is what? 0. In other words, I'm going to sum everything here and equate it to 0. Now, when I do that, I'm going to get minus 50 RL and then minus 113.14 RL and then plus 3 RL ME cosine theta E. And this should be equal to 0. Is that right? Now, after this point, you realize that RL is common to all of them. So I can say that minus 50 minus 113.14 plus 3 ME cosine theta E must be 0. Dividing through by RL, then I can write that ME cosine theta E must be what? Must be 50 plus 113.14 divided by 3. And what do you get for this? So ME cosine theta E is going to be, let's pick our calculators and then let's do 50 plus, so 50 plus 113.14. What is that? And then I'll divide this by 3. I'm going to get 54.38. Let's call this equation 1. Then I'm going to do the same thing, but this time around, summation mi ri sin theta I multiplied by li should be 0. From I equals A to I equals E, and that will be equation 2. So what I'm going to do is that I'm trying to sum everything here and equate to 0. So I'm going to get 40 RL. So 40 RL and then minus 113.14 RL minus 113.14 RL, then 3 RL ME sin theta E. So plus 3 RL ME sin theta E should be 0. All right. Now at this point, if I factorize RL out, I'm going to do plus 3 ME sin theta E should be 0. Is that right? Now after this, we know that if that is the case, then I can factorize through, I divide through by RL and say that my ME sin theta E is going to be what? So this is going to be 113.14 minus 40 divided by 3. And what is that? So 113.14 minus 40 divided by 3. And that's going to give me 24.38. 24.38. Let's call this equation 2. Now I have two equations, two unknowns in terms of ME and sin theta E. So I can ME and theta E, so I can solve for ME and I can also solve for theta E. Now let's find the angle. So this is how I'm going to do it. You know, since, so this is the, let's do this together. This is sin theta and this is going to be cosine theta. This is minus cosine theta and this is minus sin theta. Since the angle, since cos theta is positive and then sin theta is also positive, then it means we must be in the first quadrant. In other words, our y is here and our x is here. And so the angle that we want is here. So theta E is going to be the tan inverse of 24.38 divided by the cosine component, which is 54.38, 54.38. And I'm going to get, so tan inverse of 24.38 divided by 54.38. What is that? I'm going to get 24.148. 24.148. All right. So that is theta E for you. And then if I want ME, I'll put ME equals, so I can use either the cosine or the sine. Let me use the cosine. So ME is going to be what? 54.38 divided by cos theta E. So 54.38 divided by cosine 24.148. All right. And what is that? So I'm going to do 54.38 divided by cosine 24.148. So ME is 59.59. All right. So that is the mass E for you. 59.59, or let's say 59.6. So almost 60 kilograms. All right. And that is actually mass E for you. So having gotten mass E, now what else can we say? All right. Now, for what we have done here, if I want, so this was equation 2. If I want to use the other equations using the analytical method, then I'll come here. So let's call this equation 3. So this is what I want to do right now. I want to sum MI, RI, cosine theta I, and this should be 0 from I equals 1, or let's say A, to E. All right. So I'll go here and sum all of them. So 50R and then MBR. So let's do that. So I'm going to do 50R and then this one, MBR cos theta B. So plus MBR cosine theta B. And then I'm going to do minus 56.57, or let's say, yes, 56.57 R. Okay, so minus 56.57 R, and finally plus ME cosine theta E. This should be equal to 0. Is that right? Yes. So basically, we have summed everything in this column. But looking at it clearly, one thing that we can say is that this one also contains R throughout. In fact, there's supposed to be R here. There's supposed to be R. Yeah. So I can factorize R out so that I have 50 plus MB, MB cosine theta B minus 56.57 plus, now we know ME, isn't it? ME is 59.6. And then we know theta E is 24.148. Should be equal to 0. Now what this means is that I can say that MB cosine theta B should be equal to what? Minus 50 plus 56.57 minus 59.6 cosine 24.148. Now, if this is the case, then I can say that my MB cosine theta B should be equal to what? Let's pick our calculators and do this. So I will get what? Minus 50 plus 56.57 minus 59.6 cosine 24.148. And what is that? Minus 47.81. or let's say, yeah, minus 47.814, or let's say minus 47.815, minus 47.815. So let's call this equation 3. And finally, I'm going to do summation mi sine theta I to be 0 from I equals A to E. And let's do that. I'm going to take this column. So the last column, this one. Now I'll do MB. So the same thing. I think it's the same thing. So let's do it together. So I will do okay. So I will do, so this is 0 MBR sine theta B MBR sine theta B. Is that right? And then I will come and add it to, this is 40R minus 56.57R. So 40R. So 40R minus 56.57R. And then finally, I'm going to add it to MER sine theta E. So it's going to be plus MER sine theta E should be 0. Is that right? But we know the values. Okay. Let's first of all factorize R out. So I have MB sine theta B plus 40 minus 56.57. And then I'll do what? Plus ME, which is 59.6, sine theta E, which is 24.148. Okay. So I can say that my MB sine theta B is actually what? It's going to be minus 40 plus 56.57. And then I'm going to do minus 59.6 sine 24.148 degrees. And what is that? So I'm going to get minus 40 plus 56.57 minus 59.6 sine 24.148. Sine 24.148. All right. So, all right, that is it. And I'll get minus 7.812. So minus 7.812. Now, you see, with this one, sine theta is negative, cos theta is also negative. What this means is that if I draw the quadrant, so if I draw the quadrant, what will happen is that, so this is positive cos theta, this is negative cos theta, this is positive sine theta, and that is negative sine theta. If I draw the quadrant, sine theta is negative, so it will come this way. Cosine theta is also negative. It means that our theta is here. So if I want the angle it makes with the positive x-axis, then I'm coming to do all the way here. Is that right? So in other words, our actual theta B is going to be 180 degrees plus whatever we get from here, which is going to be what? The tan inverse of 7.812 divided by 47.815. So 47.815. Okay. I'm not bringing negative here because the quadrant itself indicates that it is negative. In other words, theta b is going to be what? So it's going to be 180 plus the tan inverse of 7.812 divided by 47.815. And what is that? So that's going to be 189.2. So 189.28. 189.28. So that is actually theta b. So if I want the mass b, I can put theta b in any of the equations. So let's say if I choose the sine theta, then mass b is going to be minus 7.812 divided by sine theta b, which is 189.28. And what am I going to get? So it's going to be minus 7.812 all divided by sine 189.28. And the answer for this is 48.44. 48.44 kilogram. And that is mass B. So MB is here, theta B is here, and then we know ME, and then so ME is this, theta E is this. So our problem has been solved successfully. Thank you very much for watching.